Read.
A beam is pivoted at a center of mass. It's acted upon by two forces. The negative sign is as shown. What is the resultant moment about the pivot? Okay, let me calculate this.
So try it, huh? Try it and
Yes,
let
sir.
me know the answer.
Sir.
Yes, yes. You
That's
got
not my answer.
yeah. What's your answer?
B, 25 newtons per centimeter clockwise.
25 Newton centimeter clockwise. Bangladesh.
Yes.
Okay, so can you explain how it is?
Um, um, we are giving the force in clockwise direction in the left, right? And in the anti-clockwise direction from the right. So these should cancel each other out, and the resultant force will be in clockwise.
Okay, so your answer is correct. Well done. Thank you.
Thank you, sir.
Now 6. Try 6. Read.
The driver of weight 500 newtons stands at the springboard that is 2 meter long and is fixed at point P. The springboard has a weight of 500 newtons. The center of mass of the springboard is in the center of the board. What is the total moment above point P of the driver and the board?
Yeah, get it.
And so the total moment is the moment of the driver and the moment of the springboard.
Mm-hmm.
Okay. Yeah, think the answer is D, 1,500 meters.
Yeah, what's your answer?
D, 1,500 Newton meter.
1500 Newton meter. Yes. How you got it?
Um, first I calculated the moment of the diver. It is force into distance, 500 into 2,
Mm-hmm.
that is 1,000 meter, and that of the springboard it says the center of mass is the center of the board. So
Mm-hmm.
according to the definition, center of mass is the place where it's the mass, the most of the mass acts. So
Mm-hmm.
it's 2 divided by 2, that is 1 into 500. 500
Mm-hmm.
Newton meter, I added those, I get 1,500.
So 1,500 altogether, 1,500, right?
Yes,
Okay.
sir.
Yes, well done. Thank you. Yeah, this one is the most tricky one, huh? Try it. 7.
The beam of weight 6 meters is suspended from two strings P and Q. And P is 30 centimeters from the left hand end of the beam, as shown. And Q is not shown. The center is string Q is 2 meters. What is the length in string Q and where is it attached so that the beam before we answer?
Hmm. Try it, huh? So have you got it?
I'm still thinking.
Still doing.
I need help in this one.
So you got it?
I need help.
Okay. You got two conditions for equilibrium, right?
Yes,
One is forces. Forces should be balanced and moment should be balanced, right?
yes,
Two conditions. So these two conditions we are helping us to get the answer. The first condition is forces should be balanced. Your downward force 6 Newton and your upward force is shown here 2 Newton. Now they are saying other string Q, what will be the force over there, right? That is tension.
yes,
Uh, so if we think of the first condition, that is uh, the forces should be balanced. That means if we have another 4 Newton force, another force which is 4
yes,
Newton, which is working upwards, then our forces are balanced. So the force should be 4 Newton. Then we are focusing A and B, right?
yes,
We can skip C and D. Then A and B we will focus. Now the second condition is the moment should be balanced. That means clockwise and anti-clockwise moment are equal, right?
yes,
Yeah, 6 Newton, it is the weight and it is uniform object, so it is working downwards. So for it is the pivot, right? This is the
Yes.
pivot. So here we look here at which point uh, there is not attached to any point here in the left, does it?
No.
Okay, so we have to think that if the center point here in the middle, so it is the pivot, then from here the distance or the force, whatever we are calculating, the moment is zero here, right? As the position of pivot
Yes.
is here, 6 Newton multiplied by zero, then the moment here is zero, right?
Yes.
Now we are having here one moment, that is 2 Newton, 2 Newton, and multiplied by how much?
Um. Yes.
Yeah, how much is the moment here?
Newton per centimeter.
2 into 10, right?
Yes.
2 into 10, then that is 20 Newton centimeter. So we should have another moment. This is working, we can understand from here. It is working anti-clockwise, right? Isn't it? If
Yes.
you see the position of the pivot, then you can see here it's working anti-clockwise. Then we should have one moment here clockwise. Hmm. And clockwise one should be also 20
Yes.
Newton centimeter. Now, how will make it 20? Of course, your force is there 4 Newton. So from the pivot, your distance should be 5 centimeter, right? Isn't it?
Yes.
So
Yes.
we understand that the position of it should be somewhere here, right?
Yes.
It will be then appropriate. This is 4 Newton. We can label it as 4 Newton. And the distance here we have, it is 5 centimeter, okay? So
Okay. Fine.
if it is 5 centimeter here, then this part is 15, right?
Yes.
So it's matching with B.
Oh, now I got this. Let
Got it?
me note down how we did this. Yeah.
You got it now?
Yes.
So how it is? This question, difficulty level,
Difficulty level, I would give uh, 3 out of 5.
fine. Actually, you could solve previous questions. If you could solve some more questions, that time you could be bored. That's why sometimes we give this type of questions, right?
Yes.
So that you get some interest and you are thinking that yes, you are learning something more, something new.
Yes.
Okay, now 8.
A piece of uniform car is suspended free from horizontal plane. Horizontal plane. Which point is its center of mass?
Okay, Which one you think center of mass?
I myself am confused. Which one is it?
So, which one do you think, C or B?
I am confused if it's C or B.
Okay,
I think it's
could
C. I don't know.
okay, which one you think more appropriate? If
And
you
C
think
B.
of, if you compare with B and C, more appropriate,
I think C.
yes, C. It's correct. Actually, when I saw this diagram also, I was little bit in dilemma, but according to me, this center of mass should be somewhere here,
Yes.
but it's little bit lower given C. But if you compare with B and C, it's much more closer to C, right? So
Yes.
C could be the answer.
How about we try using the diagram?
Yeah, actually,
But it makes more sense.
yeah. If
When I
you,
see the diagram, I see that it's
hmm,
supposed to be C.
yeah, this part is little bit wide, right? Hmm.
Yes.
And because of this, the center of mass is lowered here, and also here
Yes.
is some objects are missing here, right? If there was some object here and here, then it could be the appropriate place here, right? Little bit upper. So the answer is C here. Now 9.
Number 9. An object Y is in a fixed position on a rod. A weight X is moved at the position of H is set adjusted until the rod balances the pivot as shown. The experiment is repeated in a region where the gravity of movement is lower. What is done to keep the rod balanced? Should we say?
Mm-hmm.
I think the answer is D, no movement.
Both the answers, no
Yes.
movement. D,
Yes.
correct. Then 10.
For solid uniform codes have equal weight, the place of the bench as shown on the scale diagram, which code is the most stable? C. Uh,
Correct. This one is easy, right?
yes.
Okay. 11.
The middle cone is a circular basis placed on a flat surface. The stability of the cone depends on B. The diameter of its base and the position of its center of mass.
Yes.
Top. A man holds a short ladder for different positions. The weight of the ladder causes movement in the man's shoulder, in which position is the movement greatest.
Yes. Abrita, which one?
I think it's C.
Bangladesh,
No, C.
Dhaka.
No, C.
C.
Cat.
C
Yes.
for cat. Okay. They are saying the moment should be greatest, right? Where is the pivot?
Yes.
Where is the pivot?
Um,
Pivot is the
the
shoulder, right?
pivot. Yes.
So from the pivot, the distance you see of the force, right? This part, if you think of the ladder, uh, it is divided into two parts here, right? So here, this part, right side part, we have the mass, and for that one, we have weight, and that weight is working downwards somewhere here, right? As it is the center of, if you divide it into two parts, then it is the center, right? Here. Okay, and
Yes.
yeah, here is the center. So if you calculate, then you'll see the turning effect is, the moment is most in Bangladesh. And you think this part,
Oh.
it is balanced, huh? This part almost balanced, this part almost balanced,
Yes.
right side and left side, and also in A balanced. So we are getting the greatest turning effect here in Bangladesh.
Okay.
That's why he should take either of these three, A, C, or D, not in B. Then he'll lose his balance, right? This
Yes.
person. And this one is the best one, C. C is the best position because your center of mass is lowered, right? So it will be more
Yes.
stable. Okay, then
Number three, the name is Joseph Square Tire, the dimensions which are hanging Kyoto Mail. What is the center mass of the tire?
it's very simple, right?
D.
It's Dhaka, right?
Yes.
Okay, now 14.
14. Its beam is pivoted at one end as shown. The beam weighs 6 meters on its weight axis at 8 points. 1 centimeter from the pivot. A force of 4 newtons is applied to the beam, causing it to balance horizontally. In which direction and where is the 4 newton force applied? So, like this 40 centimeters from the pivot. See this out.
Yes, which one?
I think it's B. Upwards at 20 centimeters to the right of it.
Dhaka.
Yes.
Yes, correct. Should I explain or you know it? You can explain.
I understand.
Okay. Okay, this diagram is familiar with you, right?
Yes.
Okay, can you read?
About the density. Figure 1.1 shows a Peter standing on a wooden plank directly above the right support. The plank has a 3.6-meter width, 0.25-meter thickness, 0.85-meter. The gravitational field strength G is 10 newton per kilogram. The mass of the plank is 23 kilograms. The center of mass of the plank is in the middle of the plank at a distance of 1.3 meters from each of the support. Calculate the weight.
Weight. You have to calculate the weight of the plank.
Yes.
So what is the weight?
230 meters. Well,
Yes. How much it is?
230 meters.
230 Newton. Yes. Then
The movement of the plank above the right hand support.
yes.
Something you said.
Yes. Yes. I will get it.
The movement is forcing in distance, right? So could you please scroll up? I want to see if there is any mass given of the Peter.
Okay. So the weight of the plank you got 230, right?
Yes.
So from the right hand support, the distance of the center of mass, how much it is?
About 3.
1.3. So you got the distance from the pivot and the force,
Yes.
right? So what should be the answer?
Oh, the force is the mass of the plane.
Mm-hmm.
So where's the pivot?
Force is 230.
Pivot is the center of mass, right?
230 is your force, because
Yes.
weight is one kind of force, right?
Yes.
That's why your weight is 230 Newton, your force is 230 Newton, and the distance from the pivot is 1.3.
Okay.
Okay, so check now what
So
is the answer.
pivot is the center of mass.
You just you don't need to divide, just what is the formula of moment, you know. You should multiply, right?
Yes. Yes,
Force
it's very simple.
multiplied, force multiplied distance from the pivot. So what is the answer coming?
Minus 30 times it's 1.3, right? That is it.
230 multiplied 1.3. How much it
This
is?
time. Yeah. 299. No.
Yes, yes. How much is that?
299.
No, you do not need to divide it. Hello?
Then multiply it. 230 times 1.3.
Yeah, moment equals
What is this?
force into distance from the pivot, right?
Yeah.
So your force is weight, 230,
Yes.
and your distance is 1.3. Is it clear?
Yes.
So what is the answer coming?
And it comes 299.
Yes, 299. Okay, you write here 299 Newton meter. Is it clear
Yes.
now?
Yes.
It's exactly 299 or you have decimal points?
Exactly.
Exactly, okay. Then this part you read, please.
The meter moves further to the right along the plank and the plank rotates above the right hand support. Explain why the plank rotates.
Yeah, why the plank rotates farther to the right
Um,
along the plank and the
because,
plank rotates about the right hand support. So your clockwise moment is greater, right? Now,
yes.
so write that
Yes.
your clockwise moment is greater than anti-clockwise moment. Done, right?
Yes.
Okay, today till this much, huh? The rest part we will
Okay.
do in next class. Okay,
Okay,
Allah
sir.
Hafiz.
Okay, sir. So,